Okay, so from now on, we are just going to be focusing on the just the parallelogram type shapes. So these are quadrilaterals that are very specific. Okay, so what we're going to do is we're going to start with the parallelogram, and we actually will only get through parallelograms by Friday. So on your quiz will only be the polygons we talked about yesterday and then parallelograms. Then after that, we will move into special parallelograms, which are your rectangles, your rhombuses, and your squares. Okay, so that's the second half of this. And then we'll talk about other special quadrilaterals, kites, and trapezoids. Okay, so all of those shapes are going to be on your test. Okay, so that's kind of a lot of shapes and a lot of properties. So we're going to start with the very most basic shape and build its properties. Okay, so to do that, we have to start with its definition. So by definition, what is a parallelogram? Okay, I'm going to zoom in here so you can see it. Okay, by definition, a parallelogram is a quadrilateral with opposite sides parallel. So we went through a whole section and really a whole unit talking about what happens when lines are parallel. Why did we do that? Because of this. Why did we talk about what is special when lines are parallel? Because parallelograms have parallel lines. So the most basic thing we can say is, number one, obviously the opposite sides are parallel. That's one thing that you need to know. But the second thing that comes from that is if these lines are parallel, that opens up the door for alternate interior, corresponding, and consecutive interior angles. Okay, so those three things are now available to us because we have parallel lines. So, if I told you that angle Q was 100 degrees, what could you tell me about angle P? Go ahead. It's 80, right? So the first property is something you already know. Consecutive angles are supplementary. So that means they add to 180. So that means this is 80 degrees here. Okay? Scooch, I'll crouch down. Is that better? Okay, then, if this is 100 and this is 80, does that work this way as well? Because those would also be consecutive, right? So if this is 80, wouldn't this be 100? And if that's 100, wouldn't this be 80? Okay, so what's the second property? The second property is that this angle and this angle are equal to each other. Are those consecutive? Nope, they're opposite. So the second property is that the opposite angles are equal to each other. The ones that are across the way are going to be equal to each other. Okay? So a lot of your homework is going to center around trying to find angle measures inside of a parallelogram. Okay, so that's two really important pieces of information. But we're going to use a third piece of important information as well that'll help with those angles. But in order to find the third property, I'm actually going to take this parallelogram and I'm going to break it into two. And this should look super familiar because when we did triangle proofs, a lot of them looked just like that for this very reason. Okay, for these particular proofs or these particular properties. Okay, so if I break that down, we said just a second ago that we dealt with this kind of consecutive interior, but this alternate interior is also an option. Okay, so that means this angle is congruent to this one. And also, this angle is congruent to that one by alternate interior. So I used the given, I used the parallel. What's the obvious? I can mark reflexive. See, that didn't go away. You wanted it to, but it didn't go away. I can mark reflexive, and so now these two triangles here to here are congruent to each other. Great. So what, Ms. Bosenberg, right? Why does that tell us anything? Because it gives us our next property that we wouldn't have been able to say for sure. We could have said it. I think this is true, but I just proved it. Because these two triangles are congruent, I can say anything I want, which includes saying that this side is congruent to that side. And this side down here is congruent to that side up there. So are those sides consecutive? Nope, they're opposite. So the third property is that opposite sides are also equal to each other. Okay, so a lot of your homework is going to be using these properties appropriately. So look at this. There's going to be a lot of set and equal, right? Got a lot of set and equal so far. You just have to know to set those equal. Okay, so let me just show you a couple pictures on the side. So the next slide over here. Okay, so these could be two problems on your homework. It's going to say find the value of the variable. So on the first one, there's a lot of set equal. Okay, there's a lot of set them equal. So should you set 2x equal to 42? No, this is the one time that we don't set them equal. These are consecutive, so they're going to add up to 180. So it would be 42 plus 2x is equal to 180 degrees. Okay, and then we would solve that. That's it. So you have to be able to recognize the property and then know, are they equal or do they add to 180? Okay, we're not actually going to solve that, so let's go on to the next one. So then here, I got another set of angles. I've got 2x and what is that number? 50. I've got 2x and 50. Are those equal or do they add to 180? So those are opposite, so they're equal to each other. So you would set them equal and you would solve. Okay, one more variable. We've got this y. So that y plus 3 is opposite of this 18. So those we would set equal as well. And we would solve it. Okay, so far so good, right? Pretty easy. Most of those properties you either knew already or you could have guessed, right? You could have guessed them. They look equal, right? Here's the next property is the one property that you would not have guessed. Okay, so this is the next one is one where you typically would not know this. Moving in. Okay, so the next property here is going to, we're going to come down here. We're going to draw those congruent triangles again. But for this one, we actually need two pairs of congruent triangles. So I actually need you to draw both diagonals in. So one diagonal there. One diagonal there. Because I already proved some properties to you, we can use those properties as we move forward. So I already proved to you that the opposite sides were congruent, and we're really only going to focus on, we're going to pick a pair of triangles. So I'm actually going to pick this pair of triangles to focus on. Okay, so in that pair, I have this side right here is congruent to this side. So that was the property we just proved. The opposite sides are congruent. I can mark in my alternate interiors again. I could mark in this angle alternate interior to this one. I could do verticals or I could do another alternate interior. It doesn't really matter because I'm just trying to show you that those triangles are congruent to each other. And then again, it's why do you care? Why do I care if the triangles are congruent? Once the triangles are congruent, I can say whatever I want. Okay, and what I want to say is, I'm going to give this a letter here, M. Because my triangles are congruent, what I now have is I have QM is congruent to SM. More congruent, more equal statements, okay? Well, why did I choose that one instead of PM and RM? That one is congruent too. PM is congruent to RM by that CP-CTC. But let's give a name to that property. If I just cut, remember what that word is? Cut something into two equal parts. What is that vocabulary word? Bisect. So what just happened is that these diagonals just bisected each other. Okay, now that's a property, again, you could have maybe guessed that looking at the picture, but that's going to be super important when we move into rectangles and rhombuses and squares. It's not going to seem like it, like, what does that have to do with rectangles? You'll see as we get into it, but the diagonals is the one part of rectangles you don't know, right? You know rectangles have 90 degrees. You know rectangles have opposite sides equal to each other. Do you know anything about the diagonals of a rectangle? No, and that's really where we're going to focus our energy, is to kick that forward into high school. Okay, so then what is this going to look like? Again, so just a couple of pictures here, a couple of problems, and then we'll go back to that last picture. I just have a reminder. These are not the best pictures on the planet. So this 3r plus 13 is this length here. And the 9r minus 17 is this length here. Okay, so you would just set those equal, right? So they're bisected, which means they're two equal parts. So you would just set them equal. So 9r minus 17 is equal to 3r plus 13. And then separately, they could be two different variables. That doesn't really matter because they don't have anything to do with each other. So even though this piece and this piece are congruent to each other, they have nothing to do with the other two pieces. Okay, so these are completely separate lengths, so they can be completely separate letters, don't have to have anything to do with each other. So 4s minus 3 is equal to 7s minus 24. Okay. And then the second picture is just kind of there to kind of muddy up the picture a little bit and make it look a little bit more confusing. But it's still the same stuff. Okay, so here we have 3m. 3m is this length along the diagonal, and 15 is this length along that diagonal. So we would have 3m is equal to 15. And then we would have 12 minus n is equal to 2n. But what about this x business? What are those x's? One thing I just want you to look and notice is that after the 2x right there, there's a degree measure, right? So that means it's an angle. So if it's an angle, you can either set it equal to its opposite, or you can set it equal to 180 with its consecutive. So if there's a little degree measure, pay attention to that, because the degree measure tells you that this is pointing to this angle right here. And unless the other one is across from it, we're not going to set it equal. So these two are not equal to each other. So I'll just go ahead and distribute this. This is 5x plus 5, right? So we would take those two parts, 5x plus 5, plus my 2x, and that would be equal to 180. Okay, you're going to get so ingrained with the set equal, set equal, set equal to each other that when the 180 comes, it's going to feel a little bit off. Like, wait a minute, those aren't equal, so what do I do? So you're going to kind of forget about that a little bit. Okay, there's one more thing for us to talk about, and that's in the coordinate plane. So most of your homework is like that. Are you okay with that? Pretty straightforward, pretty easy, yeah? Okay, last part is on the next page here. And it's just in the coordinate plane. So let's really quickly graph the 3 points that are given. So -1, 6. And 5, 6. And 3, -1. Okay, if I just told you to do this problem without any direction, there would actually be 3 answers. Okay? Because what I need you to do is I need you to make a quadrilateral. Okay? So if you make a quadrilateral, some of you are looking at this, and can you kind of figure out where the 4th point would be? Do you kind of visually see it? Okay? Some of you are visually seeing a dot here, right? Around here somewhere. Some of you are visually seeing a dot around here somewhere. But there could also be a dot up here, right? So which one's right? The thing that you need to know is that quadrilaterals should be named alphabetically in order around the shape. Whether it's clockwise or counterclockwise, that doesn't matter, but it should go in order. So if you put your D over here, would it go A, B, C, D? No, it wouldn't be alphabetical. So where should the D go? You should connect A to B, B to C, and then D should be over here somewhere. Okay? So where it goes should be alphabetical. That's kind of how you figure out where or what quadrant it goes in. Okay? Follow the alphabet. Then where does it actually go? So to find where it goes is the opposite side should be parallel, right? But the opposite side should also be congruent. So this one is super easy for you because this is a straight line. So this straight line should also happen down here. Okay, so that straight line is 1, 2, 3, 4, 5, 6. So we're going to count 1, 2, 3, 4, 5, 6, and that is where your D should go. Okay, so you can look at the opposite sides have to be parallel, but the opposite sides also have to be equal. Okay, so let me show you the parallel part of it. So if we were going to make sure, like if the sides weren't horizontal or vertical, you could also kind of count the slope on a side and make sure that the slopes matched up. So the slope here would be down 1, 2, 3, 4, 5, 6, 7 over 2. So you could go from here down 1, 2, 3, 4, 5, 6, 7 over 2. And there would be your D. So that's another way to find it. You can either count to make the sides equal, or you can count to make the slopes the same. So D is going to be the coordinate -3, -1. And there's my coordinates for D. Okay? And then we'll save the rest of it for our lead-in for tomorrow. Okay?